Very good morning to Dr. Noor Ayana binti Awad Apandi. My name is Taihong Rachel. Today, me and my group member are going to present about the purpose and outcome of this video. The purpose and outcome of this video is to understand and able to evaluate the double integrals over non-rectangular region and the area of double integrals. First, for double integrals over non-rectangular region, according to the Fubini's theorem for non-rectangular region, there are two types of region, which is type 1 region and type 2 region. So for type 1 region, if R defined, A is smaller and equal to X, while B is bigger and equal to X. G1, if R defined G1X is smaller and equal to Y, while G2X is bigger and equal to Y. With G1 and G2 continuous on A, B, then fxydA will equal to the limit of x is from A to B, while the limit of y is from G1x to G2x.
My name is Lu Wei Jun and my role is R&D staff. And now I will talk about the double integrals over non-rectangular region for type 2 region. So this is the figure. If R is defined as y is larger than or equal to c and y is smaller or equal to d, this is a d and this is a c, and x is larger or equal to h1y and x is smaller or equal to h2y. So this is a h1y and this is a h2y with h1 and h2 continuous on c and d. Then double integration of function x and y is equal to this function. The h2y is upper limit, h1y is lower limit, while d is upper limit and c is lower limit. That's all for me. Thank you.
Good morning to Madam and all my dear friends. Now I will present the example of non-rectangular regions. So, in this equation, the domain of y is between -2 and 3, and the domain for x is between y squared minus 5 and y plus 1. So, first we sketching the diagram first. So we sketching and we know this is the regions. So when we know this region, we want to find the lower limit of x-axis, the upper limit of x-axis, and the lower limit of y-axis, upper limit of y-axis. Besides, we also want to know the intersection point of the graph. So we can combine sub the x value in this in y plus 1 in this and find the y value intersection of y intersection of x. Okay, so after we find the limits, we can we rearrange it in integration form like this. So after this, we will do the integration x first because it's dx dy. So we do the integration of x first. We integrate this for x3 plus y, and after this, after integration, we sub the value of y plus 1 and y squared minus 5. So we will get the answer. We will get the answer here. Okay, after that, after integration finish, after dx integration dx finish, we will integration dy. We are integration y. So same way, we continue to integrate the question this, and after integration, after done the integration, we will sub the value y. We will sub the value this y equal to 3 and y equal to -2. Okay, like this, and finally we get the final answer. Okay, thank you.
A very good morning to Madam. I'm Tan Ji Sing, and the role in my team is as IT manager. The topic that I want to present today is applications of double integrals area. Before I start to discuss the first question, I would like to make a simple introduction about this topic. So, to find the area of a closed bounded plane rectangle R, we have to use this formula. So, the dA could be dx dy or dy dx. So let's start discuss our first question. So here is the first question. If you look at the question, you will find that this question is request for area of R, where R is rebounded by y equal to 9 and y equal to x squared. So the first step is we have to sketch the graph, and you will get the graph like this. Okay, so if you look at the graph, there are two intersection points in this graph. So to find the intersection point, we have to do the simultaneous equation. So here is the simultaneous equation. After do simultaneous equation, you surely will find the intersection point. So here is the intersection point. So there are two intersection points in this graph, where is negative 3, 9 and 3, 9. Okay. So after find out the intersection point, you can also draw the graph like this to make yourself more understand about this question. So according to the theory, from the intersection point, we can also find the upper and lower limit for x and y. So from x-axis, the upper limit for x is 3 and lower limit for x is negative 3. So from y-axis, the upper limit for y is equal to 9, when the lower limits for y is x squared. So we will get the function like this. So when we get the function like this, the next step is we have to integrate this function. So we will get the function of y. So what it's gonna do is we replace the variable of y with 9 and x squared. So we'll get the function like this. So the same thing is after get this function, we integrate one more time, and we will get this function. So replace the variable x of this function with 3 and negative 3. So we will find the area of rectangle R. So finally, the area of rectangle R is 36 units square.
A very good morning to Madam. My name is Kokiaza, and my role in this group is as the engineer of the group. And now I'll continue the presentation with area of double integral. And this question is to find the area bounded when x squared equal to 5y and y equal to 2x. So first of all, we need to sketch the graph of this equation and find the intersection point. So to find the intersection point, we need to sub the equation 2 into equation 1, so we can get the x when x equal to 0, y will be equal to 0. When x equal to 10, y will be equal to 20. So now we will find the upper and lower limit of the graph. So here I'll draw a parallel line parallel with the y-axis. So you can see here the lower limit is x squared equal to 5y, or y equal to x squared over 5, and the upper limit will be the y equal to 2x. So for x-axis, the lower limit will be 0 and the upper limit will be 10. So here we can find the area of double integral here. So we will integrate the 1 here, so we will get y, and we sub the equation in, and we will integrate another time on dx. So we will get the area will be 33.33 unit square. So this is the answer of the second question.